Okay, so this is Algebra 1, Semester 1, uh, Lection on Sections Chapter 1.5, 1.6, and 1.7. So 1.5 deals with adding and subtracting real numbers. So first thing to note is that when we sort of think about a negative or a positive number as it relates to the number line, the negative and positive actually doesn't deal with the quantity as much as it deals with direction. So when we have a negative number on some number line, say -2, right? We have a number line 0, -1, -2, 1, 2. When we have a negative number, that tells me that I'm dealing with a number going in the negative direction, basically going to the left. Has nothing to do with the number itself. We're going to the left. When we have a positive number, that tells me I'm going to go in the positive direction or to the right. Direction, not quantity. And then the number 2 tells me how many times I'm going to go to the left, and then the number 2 tells me how many times I'm going to go to the right. Negative and positive numbers, as it relates to the number line, deals with direction. So I'm not going to focus too much on the number line. I don't really like using the number line to add or subtract things, so I'm not going to focus on that here. Absolute value only deals with distance. So I have a -4. I put it in the absolute value system and I get 4. Absolute value does not care if I go to the left or if I go to the right. It just wants to know how many times am I moving. And say, well, I'll move 4 times. So if you look at the number line here, we start from 0 and we go in the negative direction 4 units, 1, 2, 3, 4. The negative tells me I'm going to the left. The absolute value just focuses on the number itself, and the number that I'm moving is 4. You can almost consider it positive, but it's not really positive. It's just the actual distance that you move either left or right. And you know that it's the absolute value because the absolute value symbol are these two lines with a number inside. So the absolute value of 4 is 4. The absolute value of -4 is also 4. The actual number itself. Adding real numbers. If they are the same sign, if they are the same sign, you add. What do you add? You add their absolute values. You add their absolute values. So in the case of A, we have a -16, and then we're adding another -16, or rather 8, sorry. They are the same sign. Since they are the same sign, if we were going to use the number line, you go 16 to the left and then you go another 8 to the left. In the case of this, since they're the same sign, I'm going to add them. So I got 16 plus 8, which equals 24. Since both of the signs are negative, your final answer will also be negative. So that's the most important thing. Make sure that your signs are consistent. If they are the same sign, then you add. If these were positive numbers, 16 plus 8, same rule apply. Same sign, you add their absolutes. They're 24. Since they're both positive, your answer is positive. And this is how you guys have been adding numbers forever. The same thing applies with negative numbers. Same sign, you add their absolutes. If they are different signs, you subtract their absolutes. If they are different signs, you subtract their absolutes. You subtract the bigger absolute minus the smaller absolute. So negative 11, if I was to get the absolute value of negative 11, it's 11. Absolute value of 9 is 9. And then I subtract. I'm going to subtract their absolutes. 11 minus 9 is 2. Then I go back to my original problem and I ask myself which one is the bigger absolute. Oh, the 11 was the bigger absolute. What is the sign of the bigger absolute? The sign of the bigger absolute is negative. Since that sign is negative and 11 is the bigger absolute value, you go with the sign of the bigger absolute value. In this case, since it's negative, your final answer will be negative. When they are different signs, you subtract their absolute values. You subtract the bigger absolute minus the smaller absolute, and then whatever answer that is, whatever sign the bigger absolute is going to be the sign of your final answer. C looks very similar to B. We have 9 plus negative 11. Again, it's the same problem. They just switched 11 into 9. Different signs, so we're going to subtract our absolutes, just like we did before. The bigger absolute minus the smaller absolute. Since the bigger absolute is negative, our final answer will be negative. D, negative 6 plus negative 2. Their signs are both negative. They're the same sign, so I add their absolutes. Six plus 2 gives me 8. Since both of the signs are negative, that tells me that my final answer is negative, and my answer is negative 8. Same sign, you add their absolutes. Whatever the sign of the two problems is going to be the sign of your answer. Opposite signs, you subtract their absolutes, and you go with the sign of the bigger absolute as the sign of your final problem. All right, opposites. Opposites, as it relates to positive and negative numbers, are numbers of the same quantity. So I'll say same number, different signs. Same number, different signs. These guys are known as opposites. So the book gives us 3. So 3 and the opposite of 3 is negative 3. 3 and then the same number, 3, but then different signs. The thing about opposites is that when I add opposites or inverses, added inverses of each other, they always equal 0. So if I have two inverses, additive inverses, or two opposites, are going to be the same number, different signs, and when I add those opposites together, they'll give me 0. And that's called the property, inverse property of addition, or additive inverse property, which says that when I add these two guys together, opposites, I always get 0, no matter what. When we subtract numbers, we can actually add its opposite. So if we do, the book says 3 minus 5. So I'm going to say this again. When you subtract a number, you can add its opposite. So if we have 3 minus 5, the actual number is 5. So what's the opposite of 5? negative 5. And if you're confused because there's a subtraction sign in front of 5, if there is no parentheses, then we assume that the number is going to not be negative, if that makes sense. If there's no parentheses, then we assume that that 5 is positive. So in the case of that, then the inverse, in this case, will be negative 5. To subtract means to add its inverse. So it's going to be 3 plus the inverse, which is negative 5. This subtraction symbol has nothing to do with this 5. The only way that the negative or the subtraction symbol has anything to do with the 5 is when it's in parentheses. Since there is no parentheses, then we can't say negative 5, we're going to say positive 5. That is a very common mistake. Sometimes, heck, I still make that mistake. Opposite signs, so I subtract our absolutes. 5 minus 3 is 2. 5 is the bigger absolute and negative, therefore my final answer is negative. When we subtract a negative number, in this case now the 5 is in the parentheses. The negative 5 is in the parentheses. So when I talk about what the number is, it's not 5, it's negative 5. Again, the parentheses is what gives you away. That's the clue. The opposite or the inverse of negative 5 is positive 5. So 3 minus negative 5, I call it a not or a double negative. There's a minus in front, parentheses, minus afterwards. I had some students call it dancing man or sleepy guy. Anyway, if you see this symbol, that means that you're going to add. Remember, to subtract, it means to add its opposite. We're going to add, and the opposite of negative 5 is 5. So 3 plus 5 is 8. When you subtract numbers, you can add its opposite. If the negative number is inside the parentheses, then you're dealing with a double negative situation, and the inverse is actually 5, and you're adding. If there is no parentheses and there's a subtraction, then your number is 5, and you're adding a negative number. So we have 4.8 minus negative 8.7. It is in parentheses. Since it's in parentheses, the number is 8.7. What's inside the parentheses? Negative 8.7. So what's the opposite of negative 8.7? Positive 8.7. To subtract a number means to add. We're adding its opposite. Well, that's the opposite, so we're adding 8.7. And that gives me, let's see, 15. 8 and 4 is 12, 15.5. Positive. Alright, and that's that section right there. Now let's move on to 1.6, multiplying and dividing real numbers. Here's the deal. The book says if you multiply or divide the same sign, then your answer is positive. So this is how I do it. When it comes to multiplying, positive times a positive equals a positive. Why? Because I'm multiplying two of the same signs. Likewise, a negative times a negative also equals a positive. Why? Because both of the signs are the same. We're multiplying the same sign. And when they are the same sign, and you multiply them, then they're positive. When you're multiplying and they're different signs, your signs will always be negative. Positive times a negative is a negative, and negative times a positive is a negative. When they are different signs, your answers will always be negative. This also applies when you're dividing. It's the same exact thing. So when you're dividing, just like when you're multiplying, if you're dividing the same sign, your answer will be positive. So positive divided by positive is positive, and a negative divided by a negative is also positive. When they are different signs, oops, how did that happen? A positive divided by a negative is a negative, and a negative divided by a positive is also negative. Again, when there are different signs and you divide them, your signs will always be positive. When they are the same signs and you divide them, they will be positive. When they are different signs and you divide them, they will be negative every single time. So this also applies to division. This also applies to multiplication. Alright. So they give us some examples. I'll just go through a couple. 6 times negative 15. Positive times a negative, right? So I know whatever happens, my final answer is going to be negative. 6 times 15. 6 times 10 is 60 plus 30, that'd be 90. Negative 90. C. 7/10 negative times 3/5. Again, I'm dealing with a negative times a positive, so I know my final answer is going to be negative. 7/3 is 21. 10/5 is 50. Can't simplify that any further. Negative 21 50ths. Okay. Negative 4 squared. That's the same thing as saying negative 4 times negative 4. So I have a negative times a negative. They are the same sign, so that gives me a positive number. It is going to be positive 16. Whenever you square a negative number and that number is in the parentheses, your answer will always be positive. Then we have square roots. I don't like the way they do square roots in Algebra 1, but oh well. If I'll look at B. So we have plus or minus 16, or root 16. The square root of 16 is 4. That plus and minus carries over to your final answer. Square root of 16 is 4. So your final answer would be plus or minus 4. Should always be plus or minus 4. Shouldn't put a plus or minus in front, but that's me ranting and raving. Negative square root of 121. Square root of 121 is 11. Since there's a negative sign in front, your final answer is going to have that negative sign, and it's going to be a negative 11. So if there is no plus or minus sign in front, the book wants you to assume, they got a square root of 64 here. The book wants you to assume that the answer is positive. The square root of 64 is 8, so we'll leave it at 8. Dividing. Inverses. Inverse property of multiplication. If I have an inverse, when you multiply inverses, your answer will always be 1. Positive. It's always going to be positive 1. Not negative 1, positive 1 every single time. That's how I know I have an inverse. So if I have a negative 4, the inverse is not 1/4. Why? Because 1/4 times 4 is negative 1. It's not going to work. So what I need is to put a negative sign in front of that 1/4, so I have a negative times a negative, which I know gives me a positive, so I can get a positive 1 every single time. the numbers got to sum up. The product of the two numbers have to be 1. Remember that an inverse just means that the number in the numerator gets flipped into the denominator, and the number in the denominator gets flipped into the numerator. Inverses are also called reciprocals. They're dividing fractions here, and they want to explain why when you divide fractions you multiply by its reciprocal. I'm going to go with the book's example. I'm not going to write anything on the pad because it's a good example. So if I am dividing fractions, in this case I got a over b divided by c over d, I could turn it into vertical form. So it's going to be a over b divided by c over d. In some mathematical worlds, we call this a complex fraction, or complex fraction. So in the world of mathematics, this is not considered simplified. We can't have a fraction over a fraction. Some people, I sometimes call it a big fraction. It's not simplified. In order to simplify this fraction, this weird, crazy fraction over a fraction, you have to turn the denominator into 1, positive. And the way that you turn it into the positive 1 is you multiply the denominator by its reciprocal. So what's the reciprocal of c over d? Whatever is in the numerator goes into our denominator goes into the numerator. Whatever is in the numerator goes into the denominator. When I multiply these two guys, I'm going to get 1. What I do to the bottom, I do to the top. And if you're asking why that is because if we think about it, d over c divided by d over c, right? It's 1. It's like saying 5 divided by 5. It's 1. So in essence, I'm multiplying this fraction by 1. I'm not really changing the numerical value. These guys all cancel out, right? And I'm left with the number 1, which is what I want. And then look what happens in the numerator. I got a over b times d over c. This is, now that it's being divided by 1, all I have to do is write the numerator out since it's over 1, and that's going to be a over b times d over c. So this is why we say that when you divide by a fraction, you multiply by its reciprocal. They skip all of these steps and they focus only what's going on in the numerator at the end after you turn the denominator into 1. So when you divide by a fraction, you multiply by the reciprocal of the number that you're dividing by. So they want to know what the value of 3/4 divided by -5/2 is. Again, if I'm dividing by a fraction, I'm multiplying by its reciprocal. So that's 3/4 times -2/5, which gives me -3 over 10. When you divide by a fraction, you multiply by its reciprocal. Okay, so that's 1/6, and then 1/7 deals with the distributive property. When we talk about the distributive property, so 2 times let's say AB, A plus B. I'm going to sort of do similar to the book. A plus B times 2 2 times A minus B and A minus B times 2. These are all distributive properties scenarios. What using the distributive property is, it's multiplying whatever is inside the parentheses by whatever is outside the parentheses. The distributive property, there's two facets to the distributive property, but one of the facets of the distributive property is multiplying what's inside the parentheses by what's outside the parentheses. So in the case of the first one, I'm going to multiply 2 times a. Well, 2 times a is 2a. I'm going to multiply 2 times b. 2 times b is 2b. And since inside the parentheses there was an addition sign, that addition sign carries through. And my answer is going to be 2a plus 2b. Likewise here, I have 2 times b, 2 times a. 2 times a is 2a. 2 times b is 2b. And since there's an addition sign in between the two, that addition sign carries over. Here, same thing. 2 times a is 2a. 2 times b is 2b. And again, since there's a minus sign in between, that minus sign carries over. 2 times b is 2b, 2 times a is 2a, and again, since there's a minus sign in between, that minus sign carries over. So you're multiplying whatever's outside the parentheses by whatever, well, inside by whatever's on the outside of parentheses, and if there's a plus sign or a minus sign in between, those signs carry over. You can also do the distributive property in reverse. I don't know if this section gives you examples of that. So we have, for a, I'm just going to do a couple. For a, we have 5 times x plus 7. 5 times x is 5x, 5 times 7 is 35, so I get 5x plus 35, and I'm done. For b, I got 12 times 3 minus 1/6 times t. 12 times 3 is 36. That minus sign stays. 12 times 1/6, 12 divided by 6 is 2, which is 2t. So then my final answer is 2t. C, we'll do the last one. 0.4 plus 1.1 times 3, C, times 3, 3 times 1.1, C, 3 times 0.4, 3 times 0.4 is 1.2. That plus sign stays, 3.3, C. And I'm done. Whatever is inside the parentheses gets multiplied by whatever is outside the parentheses, and you carry the addition or subtraction sign. Alright, if you have a negative in front of your parentheses and it's by itself, we can put a 1 here. There is an actual negative 1 here, and we're multiplying this by negative 1 on both of these sides. Or you can say you're distributing the negative throughout the problem. There is actually a negative 1 there, but it's not. So negative 1 times 5 is negative 5. So we never write negative 1 times 5 because we don't consider that simplified. We just call it negative 5, which is the same thing as this right here. So we can rename it negative a plus 5. We can rename it negative 1 times a plus 5. It means exactly the same thing. So what we're doing is we're naming it for those who want to see it that way. Or you can just distribute the negative. Negative 1 times a is negative a. Negative 1 times 5, because it's a plus sign, so it's a negative times a positive, it's going to be negative 5. Negative 1 times positive 5 is negative 5. B, we have negative times negative x plus 31. Again, there's a 1 here if you want to write it. Negative 1 times negative x is positive x. negative 1 times positive 31 is minus 31. So x minus 31. We have also negative 1 times 4x minus 12. Negative 1 times 4x is negative 4x. Negative 1 times negative 12 is positive 12. So my final answer will be negative 4x plus 12. And then D, we have negative 1 times 6m minus 9n. Negative 1 times positive 6 is negative 6m. Negative 1 times negative 9m is positive 9n. Okay, definitions. So they give me 6a squared minus 5ab plus 3b minus 12. And we talk about terms. So terms are clusters of products separated by plus or minus sign. So in the case of this one, 6a squared is a term, and it's separated by a minus sign. So we have another term. Separated by this with a plus sign, we have another term. And it's separated also by a minus sign, we have another term. So a term, the book says, is a number, a variable, or a product of one or more variables. Notice that it says product, so it's multiplying. So it's either a number, or it's either a variable, or it's either a number times a variable, or it's a bunch of variables times itself, or it's a bunch of variables times, like A times B times C. And they're always separated by a minus or addition sign if there's more than one term. So in the case of this number here, this expression, there are 4 terms. Number times a variable, that's a term, separated by a subtraction sign. A number times 2 variables, again another term. A number times a variable, and then a number by itself. No subtraction or addition. Those guys sort of are the go-betweens in between these terms. Coefficients. So let's focus on the 6a squared. Coefficients are the numbers that are multiplying. I want to spell that long word. Coefficients are the numbers that are multiplying the variable. So in this case, we have 6, which is a coefficient because it's multiplying a squared. We have negative 5. We count the negative sign here because it's multiplying ab. And then we have 3 because the 3 is multiplying the b. So we have 3 coefficients. Blah, blah, blah. I'm not spelling that. 3 coefficients. And then you're like, well, what about the 12? What's going on with the 12? Well, the 12 is not considered a coefficient because it's not multiplying a variable. It's just a number by itself. And when you have a number by itself, we call that a constant. So in this case, we only have one constant. One constant. So coefficients, the numbers that are multiplying the variables. Constant is just a number by itself, it's not multiplying anything. In this case, the constant is negative 12. Terms, numbers, variables, or numbers times variables, or variables times variables, separated by a plus or minus sign. Those are terms. Then we have things that are called like terms. And like terms are terms where they have the variable that's of the same, variables that are the same and of the same power. So the book gives 7a and negative 3a. both of these terms have a, and both of these terms have a raised to the first power. So they're the same variable raised to the same power. They are like terms. And since they are like terms, I can actually combine them. The book says 4x squared and 12x squared. Again, same variable raised to the same power. They are like terms. What about terms that are not alike? Not like terms. Well, the book gives 6ab and negative 2a. While both of the terms have a for variable, the first one has b, and the second one does not have b. And since they both don't have the same two terms, a and b, these are not like terms. And then the book gives xy squared and x squared to the y. While they both have x and y, in the case of the first term, the x is raised to the first power, but over here the x is raised to the second power. In the first term, the y is raised to the second power, but in the second term, the y is raised to the first power. Since both the terms are not raised to the same power, these cannot be like terms. So they are not like terms. They talk about simplified and not simplified. If you have this scenario, minus 5 plus 4x. Okay. It's not considered simplified because I have like terms. I have to combine my like terms first. I have to combine my like terms. So looking at this, I would do 2, 3 plus 4 is 7. So 3x plus 4x is 7x minus 5. Then I can distribute using the distributive property. 2 times 7 is 14x, and then 2 times negative 5 is negative 10. This is considered simplified. I combine my like terms, the 4x and the 3x, to turn it into 7x. Then I use the distributive property and solved. So they give us a couple of examples. Let's go through them. 3y minus y. If there is no number in front of the y, we can put a 1 here if you want. So 3 minus 1 is 2. So 3y minus 1y is 2y. Again, I'm combining like terms. If they're like terms, I can subtract an atom. Negative 7 mn to the 4th minus 5 mn to the 4th. M is to the first power, m is to the first power, n is to the 4, n is to the 4. These are like terms. I can combine them. Negative 7 plus negative 5 is negative 12. So negative 7 mn4 plus negative 5 mn4 is negative 12 m times n raised to the 4th power. Okay, and lastly, I have 7y3z minus 6yz3 plus y3z. Okay, I could put a 1 in front of here if I want to. Y to the third, z to the first. This one has y to the third and z to the first. This one has z to the third and y to the first. So the only two like terms are the 7y3z and the 1y3z. So when I rename this, it's going to be 7y to the third power times z plus 1y to the third power times z plus, or I'm sorry, minus 6y to the first power times z to the third. 7 plus 1 is 8, so 7y3z plus 1y3z is 8. Y to the third power times z minus 6y z to the third. I can't simplify that any further, and I'm done. Okay? They have to be the same variable raised to the same power in order for me to add or subtract those like terms. Otherwise, they are not considered like terms. Okay? That is the 3 sections. Hope you have an excellent rest of your day.